In the last project, we created a function which lets us generate every parallel database to a given input database. In this concept, we're going to learn how to query this database and then measure the privacy of that query. How are we going to do this? Well, we're going to compare the output of the query on the entire database with the output of the query on each of the parallel databases. In this way, we're going to see how the query changes when we remove an individual from the database. Let's unpack this a bit. So intuitively, we want to query our database and evaluate whether the result of our query is leaking private information. As I mentioned, this is about evaluating whether the output of the query changes when you remove someone from the database. Specifically, we want to evaluate the maximum amount that the query changes when someone is removed, maximum over all possible people who could be removed. So in order to evaluate how much privacy is leaked, we're going to iterate over each person in the database and measure the difference in the output of the query relative to when we would query the entire database.
In this section, I'm going to show you how to create a function or a query over a database and then empirically evaluate the sensitivity of that function to people being removed from the database that we're querying. So we're going to query the full database, and then we're going to look at querying every possible parallel databases, and we're going to look at the output of these queries and say, what's the maximum amount that they differed? Now, an interesting thing to remember as I'm doing this is that in production, we won't necessarily use this technique to actually measure the sensitivity of a function. As we'll find in a minute, it turns out that different functions actually have a pretty consistent sensitivity, which we can know a priori. But before we jump to that, let's start with a simple query. And I think that the simplest possible query we can have on the database is a simple sum. So first, let's create a database. So let's create a database of 20 entries. And then we have every parallel database to this database thanks to the function that we created in the last screencast. Okay, so what we want to do is we want to then define a function which queries this database. And the one that we want to do first, because I think it's sort of the simplest and most intuitive, is a simple sum. So let's create a function called query, pass in database, and return the sum of that database. So query db, looks like there are 10 ones in this database, right? So if we recreate it again, looks like sometimes there's 13. Obviously, since this is a randomly generated database, the number of ones in the output of this query tends to change. However, if we look at this database, it's 13, and then we query parallel database 1, oh, there's only 12. For a lot of these, there's only 12. So as you can see, when we remove people from this database, it changes the output of the query. What does this mean? What this means is that the output of this query is actually conditioned directly on information from a lot of people in this database. And so as it turns out, if this wasn't true, right, if the sensitivity was say 0, then that would mean that we get the same output of the query regardless of who we remove from the database. Now, obviously, this is not the case for some, but there could be functions later which do have 0 sensitivity. Let's actually look and see what is the maximum amount that this query changes when we remove someone from the database. So we're going to iterate over every single person in the database, all these parallel databases, and just compute the query for them, and then see what's the maximum amount that they change from this query over the full database. Right? So let's call this the full result, right? So the full query, or full DB result, a little more intuitive. And now let's iterate over every parallel database. So for PDB and PDBs. As you recall, this is a list of databases. And then we're going to compute a parallel database result equals query PDB. And then we want to evaluate the distance. So like we'll say the max distance is originally 0. And then we want to make a comparison between this PDB result and the full DB result. And we actually don't care about the sign here. We're just looking for the absolute distance, right? As you might remember from the previous, I mentioned that this was called the L1 sensitivity. And this is because we're computing this sum directly. If we were to square this, it would become the L2, just like sort of L1, L2 norms, these kinds of things. This DB distance equals this. And then if DB distance is greater than max distance equals DB distance. And so let's see what our max distance is. Our max distance is 1. Now, let's think about this for a second. Why is our max distance 1? Let's actually make this database a lot bigger. So we do it, we'll say with 5,000 people, right? And see if what our max distance is. Oh, look, as you can see, our max distance is still 1. Well, as it turns out, our database is a binary database, right? So all of these entries in the database are either 1 or 0, which means that if we're computing a sum over it, the maximum amount that the output of a query could change is just by 1, because you're removing a person from this database. This teaches us something, right? So sum actually has a consistent sensitivity. So even though we're calculating it empirically here, we're actually, we're iterating through the data and like seeing how much it changes, this is actually an unnecessary step. Like we don't have to do this because we know something about our database, and then we know something about the function that we're computing on a database. We know that the maximum value of any value in this database is a 1, and the minimum value is a 0. So the most that anyone could change a sum query is 1 minus 0, which is 1. Right? So this is max distance. So intuitively, just for the purpose of teaching sensitivity, we're walking through this sort of explicit calculation, and we'll continue to do this just as like a teaching tool. In real world production use cases, this would be inefficient and sometimes inaccurate if you happen to have a database that had all zeros in it, for example. When you actually do this in the real world, the a priori knowledge that you know about your database, like the maximum, minimum values, and the query that you're computing, is actually sufficient to know the sensitivity. So let's go ahead and actually rename this. We could probably rename this like empirical sensitivity instead of just calling it sensitivity, but for the sake of just teaching these techniques and getting an intuitive feeling for what sensitivity is all about, I think that this is going to be sufficient.
Now this definition, the maximum amount that the query changes when removing an individual from the database, has a specific term. It's called the L1 sensitivity, or simply the sensitivity for short. And this is going to be an incredibly important measure because it allows us to understand an aspect of a certain kind of query. It's actually going to ground our later analysis comparing how different queries do or do not leak information. In this particular case, a sum actually leaks quite a bit of information. The output of the sum is conditioned on every single individual that has a 1 in their row of the database. In the next section, we're going to write some more code to check the sensitivity of any function generically.